parallel cylinders, or you can machine short tapers by using the compound slide. But you begin by setting the machine, as I have done here, with the witness marks approximately in line with one another. The way that you set this is by using two screws which are in the base. And you'll notice that I'm loosening them both. Now, I'm not able to tell you which way you must do this on your particular lathe, because every lathe is made differently. It's up to the manufacturer. But you see, as I tighten that screw, you can see that this witness mark has moved. So this is where I begin my operation, by loosening up these screws and adjusting the tailstock position as accurately as I can to bring the witness marks in line with one another. As I'm tightening that up, it's moving back. You see the tailstock is moving across in that direction. It's moving away from me. And I'm bringing it in. And at that point I have the witness marks right about in line with one another. So I tighten the screw on the opposite side. And that's about as much as I can do with setting that to begin with. Now, it will be reasonably accurate, but it will not be dead accurate the way we're going to have it in a few minutes. The first thing that we have to do is to make a test bar, which we're going to set up on centers, and we're going to use that to determine the exact degree that we want. In order to make the first test bar, you should cut off a piece of round steel rod. I use 1 inch diameter. That's a very convenient size. And you're going to want about a 10-inch length. And we're going to go through the machining steps and show you how to set that up. The thing that you're going to need to make your test bar is to set it up so that you can accurately machine the ends. The best way to do that is to support one end of the test bar in your 3-jaw chuck, while you support the other end in your 3-point steady rest. As you put the steady rest in position, wipe the ways a little bit to be sure that there are no chips under it, because you want everything to sit as solidly and as straight as possible. You'll need a tool on the tool post with which you can take a facing cut and with which you can take a turning cut. And you'll need the tailstock drill chuck with a medium-sized center drill in it. What you're going to need to make your test bar, in addition to the short piece of steel rod, is that you should set up the 3-jaw chuck on the headstock of the lathe, and you should put your fixed steady rest in place. When you put the fixed steady rest in place, wipe the ways to be sure you have no chips or anything under it. This will help to promote accuracy. You'll want a tool on the tool rest, which will be used for both a turning cut and for a facing cut. You'll begin with a facing cut, and you will also want to be using the tailstock drill chuck with a medium-sized center drill in place. Now I'm going to put the test bar into place, bringing it into the chuck, and then tightening the chuck jaws. At this point, it should rotate nicely as I pull it over by hand, and it does. We have everything in good alignment. You have to be careful with the 3-point steady, because you want this all to be on the axis of the lathe. You want the rotation to be as nearly perfect as you can get it. Since you haven't checked your lathe out yet, it's possible that you'll be off a little, but try to bring it as close as you can. At this point, we can bring all of the jaws of the steady rest into contact with the workpiece, and now it's ready to begin the machining operation. Advance the tool into the end of the work so that you can make a facing cut. Cut from the center out. I'm just barely bringing the tool into contact with the work at the present time. I'm removing a little bit because the end had been saw cut, so it was really quite uneven. In fact, it was a little more uneven than I realized. I'm going to put a little cutting oil on that because it cuts better when the work has an oil to cool the tool. We're getting a uniform chip lifting off, so the work is coming along okay. Now I have a continuous machined surface on the end of the workpiece, which I know is square because I just machined it. So I can move the carriage out of the way. And bring up the tailstock drill chuck with a center drill in it. Now I can slowly begin to drill the center away. We want to drill a good solid pocket in the end so that we can support the end of the bar on the lathe center, and we want enough of a reserve in there to hold the lubricant while we're running it. This lathe is fairly well aligned because I've aligned it in the past. I just moved it, as you saw when I was showing you how the tailstock sit-over goes, but I've been running this lathe for so many years and I know it so well that without any further checking I have it quite close to being exactly on. The test bar that we're making here is really a tool in its own right. It's a useful accessory that you will protect and put away, and you will always have it to use for your own machine. And if a good friend of yours down the street tells you, I can't get my lathe lined up, you can take it down and do it for him in a matter of a few minutes, and he'll probably be your friend forever. The center drill is cutting in very nicely now. We're up to the tapered part. Don't cut in too far because you don't want to get into the parallel part of the center drill. That will ruin the accuracy of the end. You want a tapered entrance hole. Now that completes the machining on the first end. I'd like you to take the bar out of the lathe and reverse it, and repeat the same procedure on the opposite end. Then you'll have both ends of your test bar machined off straight and at right angles to the bar, and you will have both ends of the test bar center drilled so that you can do further work with it. There is the way the end of the bar should look. And you will want both of the ends to be machined in the same way. Now for the next step in making your test bar, you're going to want to do a turning cut in the lathe. So you should begin by putting on a catch plate in order to drive the work, because we're going to work between centers. That's the most accurate way that we can handle making the test bar. Put the catch plate on the headstock and put in a dead center. Put a center in the tailstock, a live center if you use them, or a dead center. It's the type that I use here. Now I've prepared the workpiece just as we've shown and discussed. Each end has been faced off and center drilled. In addition, I've attached a lathe dog to one end so that I can mount this workpiece between centers. Don't forget to put some lubricant in the end that's going to be running on the tail, because that center will not be rotating. Now the lathe is set up, and we're all prepared to take a turning cut on this end. The turning cut we're going to take is going to be a short one, only about 1/2 of an inch or so, and there's no need to work to any specific diameter. Whatever diameter you turn will be fine. You don't have to remove a lot of metal. If you take away 10 or 15 thousandths of an inch, that will be just fine. I have the workpiece set up now between centers for turning. I'm driving it with a lathe dog from the catch plate, and I want to take a short turning cut on this tailstock end. I'm going to cut for about 1/2 of an inch, and I'm going to remove 10 or 15 thousandths of an inch. The exact diameter is not important. I recommend that you put your lathe on automatic feed for taking the cut, so that you will have as smooth a job as you can possibly get. You see the tool is just beginning to lift a light chip from the workpiece now. And that's exactly what we want. It's cutting all the way around, and it's going to leave a nice, freshly machined surface. The point in machining this 1/2 inch piece is that this is going to give you a very accurate surface which you can touch with your indicator when you're using this as a test bar. Now that the turning cut is completed, you can remove the test bar from the lathe. And there's the way the end should look. You see it has a nicely turned shoulder, which is very accurate, because we've just turned it between centers, and it has the accurate center drilled spots on both ends so that we can mount it between centers. The length of the test bar is not critical. I've chosen 10 inches as a convenient size because I'm working on an 18-inch lathe, and if I am able to place everything accurate within 1/2 a thousandth of an inch or so over a 10-inch span, I really have the lathe pretty accurately aligned. If you're working on a different size lathe, you may wish to use a different length for your test bar. If you're working on a long bed lathe, you could increase the length to 12 or 14 inches if you want. I really don't think it's necessary to go beyond 12 inches even on a long lathe. If you happen to be working on a short bed lathe, you may wish to reduce the length, and I would be a little bit skeptical about going below 6 inches because that's getting to be a little bit too short. But this is the way you've made your test bar. It's an accurate piece. It's as good as your micrometer, and it's something that you should protect and put away. You can use it on this lathe on which you made it, or you can use it on any other lathe in which it will fit. So we're going to go on now and put this piece of tooling to work. When you begin to set your lathe up to do very accurate work, I recommend that you have an indicator. The one that we're going to be using here is a standard indicator. It's calibrated in thousandths of an inch, and it has a 1-inch travel. If you have an indicator which has a smaller travel than that, for example, a 1/2 inch or a 1/4 inch, that's fine for this job. In fact, if you have one of the little centering indicators which goes 10 or 15 thousandths of an inch each side of center, you will be able to use that. As we get into doing tapering work, an indicator which has a little greater travel is more convenient to use. I have an indicator mounting here which I made for the lathe also. You'll notice that it has a clamping piece at the bottom, and it's simply made so that I can insert the indicator in the hole and I can lock it in place by this knurled thumb screw. I made this in the shop because I made this especially for my South Bend lathe. The hole that I drilled for mounting the indicator is exactly on the lathe axis. In other words, I measured from the top of my compound rest where this tool is mounted, so that from this bottom surface to the center height of where the hole is drilled for the indicator coincides exactly with the center height of the lathe above the top surface of the compound rest. So I can slip this into place and tighten it down, and we're ready to begin making some measurements. It doesn't have to be tightened down extremely hard, but you want it to be tight enough that it's not going to move under anything that you apply to it. Now I'm going to tip this over into a position where you'll be able to watch the hand on the indicator so that you can see exactly what I'm doing. With the indicator in place, I'm ready to put my test bar in between the lathe centers. Be sure that it's mounted firmly, and notice one thing. As I put this between lathe centers, the part that we turned very accurately I have turned toward the headstock of the lathe. There's an important reason for doing this. You'll remember that we said the headstock of the lathe is built in essentially a fixed position, and you don't want to be moving that or working around with it. So this means that this becomes our reference point, and this is the way that we will begin, by putting our test bar in place so that we can take a reference reading from this machined surface at the head end of the lathe. Now as I run this in, I'm bringing the contact point of the indicator against the work surface, and you can see the position that this is, that my indicator is centered exactly on the center height of the lathe. So whatever readings I'm taking are directly from the center of the lathe. I run the cross slide in far enough to give a deflection of the needle, which is a good solid reading, and then I turn the bezel so that I get a 0 mark on the needle. Now, at this point, I don't want to move anything. If you want to, you can tighten the gibs and lock your cross slide in that position. I have them set up fairly firmly, so I'm not going to lock them. I'm going to let it sit in this position because I know that the cross slide will not move. Now I can loosen the test bar, and as I do, I pull back on the indicator. The indicator has a knurled ring at the top, and I reverse the bar end for end, and I let the indicator contact go back in. Now, without moving the cross slide, I pull the indicator back so that it doesn't contact the bar, and I run the carriage to the opposite end. When I get in position over the machined area on the test bar, I let the contact go back against it. Now you see what I've done. This center point and this center point are defining where the axis of the lathe is at the present time. When I took my indicator reading at this end, I measured an exact distance from the center axis of the lathe. By reversing the bar, I've moved that exact distance down to the tail end, and as I let the indicator point come in contact with it, I am measuring the exact distance from the axis. In other words, I have defined where the axis is. If my indicator reading is still 0 when I take it at this end, I know that I have this axis exactly in line with the ways of the lathe, because this is where the carriage traveled. If I have some deviation from a 0 reading, I know that the axis is offset in one way or the other, and I will correct that by using the set-over screws as I showed you before when we made the rough alignment. Now as I check this, I find that I have about a 5/1000th of an inch deflection showing on the indicator, which means that I have to move the tailstock by approximately 5/1000ths of an inch. Leaving the indicator in contact with the workpiece, I loosen each of the set screws that are used for adjusting the tailstock, and now I make a shift in the tailstock by tightening one side. I have to loosen the hold down bolt. I made it just a little bit too tight. This hold down bolt, you see, passes right through the entire base of the tailstock, and by making it too tight, I've made it too difficult for me to shift the set over setting. So I'm putting this back into position. Now as I move this, you see, as I do it in this direction, I'm getting the offset worse and worse. You see the deflection is increasing. But as I tighten from this side, I will be able to shift it back. I have to loosen this side a little bit. You can see that the needle is coming back, and I bring it back until it's exactly on the 0 position. When my indicator shows exactly 0, I know now that I have moved the tailstock over so that it's exactly in line with the headstock. When I get the exact position that I need, I tighten the opposite screw, and my lathe is aligned. That's all there is to it. At this point, I know that I have made the situation in which the center line of the lathe traveling from the tailstock to the headstock is exactly uniform with respect to the ways of the lathe, and I should be able to turn a perfectly cylindrical workpiece. That's a very quick, easy adjustment. Now what happens if you set up and you begin to work and you find that your work is not cylindrical? In other words, that you're machining some kind of a taper. The first thing that you do is reverse the bar, put it in at the headstock, the turned end, repeat this entire check that we did, reverse it so you're measuring and determine what has happened. If everything still looks in line, there's another step that you have to complete, and we're going to show you how to do that also. All right, now we're considering the hypothetical case in which you may find that your lathe is in very bad alignment. You've gone through the work with a test bar, checking to get the tailstock set over to match against the headstock, and you find that it still turns tapers on you, so what to do? The next thing to do is to consider whether the axis of the lathe is truly horizontal and parallel to the ways in the horizontal plane. You still use your same test bar to check that, but the check has to be done in the vertical position. I've mounted an indicator on the compound slide so that it's sensing vertically, and as I run this in, you'll see that I get a deflection on the needle in which it increases and it increases and it increases, and at a certain point it begins to decrease. The point that you want to feel for is the maximum point which is right about there. That means that you're exactly over the lathe axis, and you're measuring in a vertical direction the distance between the machined surface on your test bar and the lathe axis. When you find that point, change the collar on your indicator so that you record it as a 0 point. Then you can back the cross slide off. Now once again, you can reverse your test bar so that you can repeat this measurement at the tail end of the lathe without changing the position of the cross slide. Run the carriage back, feed the cross slide in, work it across, and you see that you come to some reading. Now the reading that I'm coming to here is a couple of thousandths below the reading that I had at this end. This tells me that my tailstock is sitting a little bit too low. The only way that I can correct that is by inserting shims. There are two bearing surfaces in the tailstock, one at the back end and one at the front end, and I will have to insert a shim in each one so that I raise the complete tailstock. Now, this may get to be a frustrating job, and if you begin to feel aggravated, take a walk for a little while and come back. You see what happens? This point where you're measuring is quite far out from this one, which means that there is an amplification factor. If you put a shim in here, as we read here, about 3 or 4 thousandths, you think you should insert a 3 or 4 thousandth shim, should bring everything up, it should be fine. You may find that it's not, because you may find that because of the amplification in the tip of this tailstock, that you will actually get a reading where it will move out by 7 or 8 thousandths. And you have to go back and forth and work until you get that exactly at the same height. But you can go back and check your reference end, and you can come down here and you can check as we've done here. And each time you do it, you should be able to get closer and closer. Take your time and get it so that this plane is exactly parallel to the lathe ways. This function is just as important as the tailstock set over, because when your lathe tool is set to be exactly on the lathe axis, if this happens to be inclined, whether it be tipped up or whether it be tipped down, as your tool cuts, it's going to be farther away from the center at this end than it is at this end, which means that your work will always be larger at the tailstock end if there's something wrong with the height adjustment of your tailstock. So this is one of the things that you want to work for. Work to get the tailstock set over exactly right so that you have the axis parallel to the ways. Work to get the tailstock height exactly right so that the lathe axis is exactly parallel to the ways. The headstock is your reference. All adjustments must be made in the tailstock.